Hello, it's Keith here, and this is lesson 8 of the YQuest series of 68000 assembly programming tutorials. Now, today we're going to go back to the x68000. Before we were using bitmap graphics, and now we've got an upgraded version that's actually using hardware sprites. Now, the difference on this system is negligible because the bitmap graphics were very good and flexible and allowed very smooth movement anyway. But if you see when my cursor overlaps the text here, you can see that the transparency is working, so we are definitely using hardware sprites here. Now, the reason I've done this, even though there's not really any significant visual improvement, is there is very little documentation on hardware sprites on the x68000. So I thought as a sort of tutorial, it was very important to do this, even though the actual improvement to the game was basically non-existent. So that's what we've done today. We're going to go over to the source code and we're going to learn how we've upgraded YQuest to support hardware sprites. Okay, so here's the YQuest8 code for the x68000, and this is the version you just saw with the hardware sprite. Now, there's been a couple of changes to the multi-platform code. Firstly, we had an unused byte of the object definitions. Now it is the hardware sprite number. You see, hardware sprites can't coexist in two positions on the screen at the same time. So hardware sprite 1 could be here, or it could be here. If we want to have two objects at the same time, one has to use hardware sprite 1 and the other has to use hardware sprite 2. So that's what we're doing. We're using hardware sprite number here to define which hardware sprite is being used. A value of 0 or over 128, effectively 255 for our purposes, are defined as still software sprites. 1 to 127 are defined as a hardware sprite, and we'll be using one of the hardware sprites to show the object when that's defined. Now, the reason 0 and 255 aren't hardware sprites is because 0 is how most of the objects initialize and 255 is how the bullet array initializes. So by ignoring those, we're effectively skipping any objects that haven't been given a hardware sprite number. Now, we've made some changes to the multi-platform code, and not in that file. I'm looking at the wrong file. Hang on a minute. Here we go, this is the right file. Now there's this new function called set hardware sprites. This will effectively set the hardware sprite number of consecutive objects, because when the game starts, we'll need to allocate one of the hardware sprite numbers to each object we want to have a hardware sprite, which in this case is all of them. So that's what we have to do there. We'll be seeing that function in use later. And the other change is here. The code that draws the objects to the screen now has a new check, and any value between 1 and 128 is considered a hardware sprite and uses the new doGetHSprite object. Any software sprites are being done with the original code. Now, the original code is still doing the fonts for the screen, and on some of the systems, not this one, but on some of the systems where there aren't enough hardware sprites available, we're kind of splitting things up and doing some of the sprites with hardware and some with software. That's certainly not a problem for the x68000 though, because the x68000 has a huge number of hardware sprites. Okay, so let's actually look at the code of the x68000 version of YQuest and we'll see what has changed. Now, the first thing is our screen initialization here is unchanged, but we've now added some extra code here, and this is initializing the screen layout for the hardware sprites. This would need to change if we were using a different screen resolution. The settings for each screen resolution, as best I know them, are on my website. Also, we need to turn on hardware sprites with this function just here. Now, as that will enable the hardware sprites, but there's a couple of other things we need to do. The hardware sprites do not use the same palettes as the regular sprites. We're using different palettes. The basic palettes are at E82000. The hardware sprite palettes are E82200. The format is exactly the same, and for our purposes, we're just using the same colors. So we're just transferring the same palette to that extra bank of colors there. Now, the hardware sprites use a different format of data to the bitmaps. We're having to use a specific format, and so we've got that in memory just here, and we've got to transfer that to the hardware sprite RAM, and we've got a function called define sprite to do that. Each sprite uses 128 bytes, and we have to move them to the address EB8000 onwards. Now, these are the patterns that we can then use later on in our hardware sprites. Now, if you're going to make hardware sprites for the x68000, you can use my YQuest8 editor as always. And these are the original bitmaps that we used, but on the x68000, the hardware sprites are always 16 by 16. So we need to change them a little bit. And if we go to the tools menu here, sprites and sprite space 8 by 8 to 16 by 16, you can see it's shifted all the sprites out so that they basically are the right size and the extra pixels are now unused. And then we can just go to 68000 and x68000 and save sprites, and that will save in the correct format for the x68000 hardware sprites. So that's what we've done there, and that's defined the data in the correct format for the hardware sprites to be used here. So that we've transferred them there, and that's basically the end of this part of the code. Now, at the start of the game, we're having to allocate hardware sprite numbers. Now, the player's hardware sprite is defined in the player initialization, but all of the other ones are defined using the set hardware sprite function that we saw earlier. So we're pointing to the start of an array, an object array, giving them a sprite number of 2 and onwards, and then the count is being loaded here. So we're going to fill all of the player bullets with hardware sprite numbers, consecutive hardware sprite numbers, and then continue for the enemy bullets, and then continue for the objects. And this allocates a hardware sprite to all of the objects. If we didn't do part of the objects, they'd still keep using the old software sprites, which would be okay, but it wouldn't be ideal. Now, when it comes to actually removing a hardware sprite from the screen, we're going to need to do that during the clear screen, because we don't want all of our objects appearing on the screen after the game over. Would be a bit unfortunate. So we're going to use this blank sprite hard function to remove a sprite from the screen. And what we're effectively doing here is we're moving the position to 0, 0, which takes the sprite into the invisible area of the screen, and that will get rid of the sprite so we don't see it anymore. That's a quick, easy way of removing the hardware sprites from the screen. Now, before we had that doGetSprite object, which would draw an object with the software code from the object definition, the 8-byte object definition. It would load in the XPOS and the YPOS and the sprite number and things from that object definition. We've got a new doGetHSprite object function, which will load the same settings in the same kind of way. We're calculating the hardware sprite number this time. There are 16 hardware sprites per bank, so we're working out the frame there, adding the hardware sprite number there, and that's effectively going to be the tile pattern that we're going to use for this hardware sprite. We're then calculating the X and Y pos, adding 16, 16, because 0, 0 is actually off the screen, as I said. And we're just setting the palette 0, setting the priority above all of the bitmap layers. And then it's actually this set sprite function that's doing the work of configuring the hardware sprite. So if you were transferring this code to your own game, you would probably want to ditch this and just use this set sprite function, which is actually doing the work of allocating one of the hardware sprites with a position and with a pattern and things. Now, each of these use 8 bytes for definitions, and there's a 2-byte XPOS, a 2-byte YPOS, there's a priority there all on its own, and then there's the actual hardware sprite pattern number here, the color here, and V and horizontal flip. Now, each hardware sprite number uses a total of 8 bytes, so we're just multiplying that up here, and the definition base of the hardware sprites is EB quadruple 0, and that each 8 bytes there will define one of the hardware sprites. So if we set those, then the hardware sprite, assuming we've given it valid data, will appear on the screen. So that's how we actually define a hardware sprite, and then you can just see here the hardware sprite patterns there that we've transferred to video memory. So that's all there is to it, to using hardware sprites on the x68000. As I say, it's actually very easy. It's just a shame that it was relatively little documentation. It did take me a long time to get working in the first case, but once you've got it working, it's not unpleasant at all. It's quite straightforward, relatively speaking. So hopefully, if you're interested in the x68000, you'll be able to go to my website, download the source code here, and you'll be able to see hardware sprites in action. I have already done another tutorial showing hardware sprites in the platform specific series, but I thought it was definitely worth another one just because, as I say, it's such a under-covered subject. So there we go. If you've liked what you've seen today, please like and subscribe. If you like the videos, YouTube recommends them to more people, and I can assure you my videos are so niche they don't get many views, so it would help out. Also, if you subscribe, it just generally encourages me to make more videos, and hopefully you'll get told about videos you might be interested in as well, which is an added bonus maybe. But anyway, whatever you do, I hope you enjoy your 68000 programming, and I hope you have some fun with the x68000. Thanks for watching today, and goodbye.